I welcome you all for this lecture series on deep learning. In this lecture, we will discuss about the topic sequence modeling in RNN. The sequence modeling condition on the RNN is a fundamental concept but it is a fundamental concept because most real world data does not occur in isolation but unfolds over time where current events are strongly influenced by past information. Learning this topic helps us understand how models like recurrent neural networks capture memory and temporal dependencies, enabling them to make meaningful predictions in applications such as language understanding, speech recognition, medical signal analysis, and time series forecasting. By studying context conditioned sequence modeling, we gain insight into how intelligent systems mimic human thinking, remembering previous experiences to interpret the present, making this concept essential for building accurate, reliable, and realistic AI systems. First, we'll see one by one. The sequence modeling conditioned on context, that is RNN. The RNNs are designed, the first point is the RNNs are designed for sequential data. That means what do you mean by the RNN data are designed for the sequential data? In the sense, the recurrent neural networks are built to process data that arrives in specific order, such as words in a sequence or reading in a signal. Unlike traditional neural networks, RNNs handle one element at a time while maintaining memory of previous elements. This we'll see it in the equation. So here, each output depends on the current input and past context. In RNN, the output at any time step is influenced by both the current input and the information stored from the earlier steps. So here what it says means the output depends on current input and the past context. In the sense what? The RNN at the output at any time step is influenced by both the current input and the information stored from the earlier steps. This dependency allows the model to understand evolving patterns over time, and the context enables memory in a sequence modeling. Context refers to the accumulated information from the past, which is stored in the hidden state and fast forward. This memory helps the network to make informed predictions. Say, for example, in the equation, we can say that this is the current status and it depends on the past case and the input. Function of h of t minus 1. If h of t is equal to function of h of t minus 1, comma x of t. So, one example I'll tell you. When I'm listening a long explanation in the class, let us take, if you are sitting in the class, you are listening long explanation of my class. I'm listening to a long explanation in a class. I don't forget what the teacher said at the beginning. My understanding of the current sentence depends on what everything explained earlier. This is the best example. And what is sequence modeling? Sequence modeling handles ordered data. First point is sequence modeling handles ordered data. Sequence modeling focuses on data where the order of the element matters, such as time series data, speech, or text, and the input order affects the output. Changing the order of the input changes the meaning of or result, which makes sequence modeling different from static data processing. And the time dependency is important. The relationship between the earlier and later elements must be captured to produce meaningful predictions. The equation is given by x depends on what? X1, x2, x3, and up to xn. So here the relationship between earlier and later element must be captured to produce the meaningful predictions. The one example I'll tell you, if I hear the numbers 1, 2, 3, here, let me take x1, x2, x3, up to xg. Otherwise, 1, 2, 3, etc. I understand counting 1, 2, 3 like that. But if the order changes, the meaning changes completely. So instead of giving one x1, x2, x3, x4 means it is a sequential order. If I am changing x2 here and x3 in the second place and x1 is fifth place, like that, the completely the meaning will be changing. That mean it changes completely. So this will order here. What it matters means in the sequential model, order matters 1, 2, 3, like that, x1, x2, x3, sequential order matters. And meaning of the context means context represents the past information. That is ht means h of t minus 1. Context is the information learned from the previous inputs in the sequence but influences the current predictions, and it's stored in the hidden state. The hidden state acts as a container that stores and updates this contextual information, and it helps interpret the current state. Without context, the current input alone may not provide enough meaning. And the equation is given by CT context. CT is equal to H of T minus 1. So it depends on what? The past state. So without the context, the current input alone may not provide the enough meaning. So an example I'll tell you, when someone suddenly says, that was amazing, I only understand what they mean because I remember what happened just before. Just if colloquially if you are speaking. Next, hidden state representation. The hidden states act as the memory. The hidden state retains useful past information needed for future predictions, and it carries the information forward in time. It carries the information forward in time. As the sequence progresses, the hidden state transfers relevant information to the next step and updated at every time step. Each new input updates the hidden state and refining the stored context. And the equation is given by h of t is equal to tan h of wh h of t minus 1 plus wx into x of t. It improves. While driving, I remember the traffic situation from a few minutes ago. So I can decide whether to slow down or speed up now. So based on the condition, I can move off. Next, conditioning output on context. So the output depends on what? What I have said. Output depends on what? Hidden state. No doubt in it. The hidden state contains past information. So outputs are naturally influenced by the context. Next, hidden states already contain the context. Means there is no need to store context separately. It is embedded within the hidden state, and it enables the informed predictions. This conditioning allows the RNN to make intelligent and consistent predictions. And the equation is given by y of t is equal to g of h of t. An example I'll tell you. If someone asks me, is it safe? We do not know what it is. Is it safe? My answer depends on the earlier discussion, not just the single questions. If I know the previous information, I can say is it safe means I can say yes. Otherwise, I can say no. Next, RNN forward pass. Input is processed step by step. Input is processed step by step. RNNs read input sequentially rather than all at once. And memory is updated. Here, the memory is updated at each step. The hidden state changes with every new input, and output is generated sequentially. Each step produces an output based on the updated memory. H of t is equal to f of x of t plus here the previous output x h of t minus 1. So for example, when I cook a dish, for this case I am telling you an example. When I cook a dish, each step depends on what I have already done. If I added salt earlier, I won't add it again. So that only the output is generated sequentially, and memory is updated at each step, and input is processed step by step. The cooking example is the best example. Contextual dependency across time. The first point is here what it says means the earlier inputs influence later outputs. Information from the beginning of the sequence affects later predictions. Long term patterns are captured, and long term patterns are captured. RNNs learn trends that develop over time, and it is essential for meaningful sequences. This dependency is important for language and signal understanding. The equation is given by P of yt for given x1, x2, xt. And the example is, when I hear I went to the bank, I wait for the next words to know whether it is a river bank or a money bank. So, how can, in this way only the system will identify. Just if suppose, simply if I am saying, I went to the bank, when I hear somebody is saying I went to bank, I may be confused whether he has gone to the river bank or a money bank. Next, whom the first example, the words are processed first example is, the words are processed sequentially. Each word updates the understanding of the sentence, and meaning depends on what, the previous words. Earlier words provide grammatical and semantic context, and the context improves language understanding. This allows accurate predictions of the next word. It is given by ht is equal to ht minus 1 plus word of t. It improves. Say for example, in this case, what is the example I want to say means, a doctor never decides based on one heartbeat. They observe several heartbeats over time before concluding anything. It's suppose if person is going for some ECG, EEG analysis, he will not consider only one. That is heartbeat. He'll take many observation, many experimentation. He'll be doing it. The best example, ECG signal analysis. If you are taking, each heartbeat depends on what, past heartbeats. Medical patterns. Medical patterns emerge only over multiple beats, and here the patterns appear over time. RNN detect trends rather than isolated values. And here the context improves the diagnosis. Using history leads to better health predictions. And H of t is given by F of ECG t plus H of t minus 1. And just like a teacher understand a student's performance by observing them over the whole semester, not one test. So he will the students will be monitored by all the tests, all the assignments, everything. No, his performance will not be considered, will not be given by considering only one test. So coming into the application, it is being used in many applications. The speech recognitions. RNN understand spoken words by analyzing sound sequences, and machine translation. The translation depends on, the second point is the machine translation. The translation depends on what? The first is speech recognition. A second one is the machine translation. The translates depends on previously translation words. Time series and medical analysis, it is being used. RNN predict future values using historical data. Say for example, y1, y2 up to y1, y2, yt. Sequentially, it will go for it. If I watch only the last 5 minutes of the movie, I won't understand the story. So here the context is the context is essential in this case. If sequentially, if I am watching, let me consider this is the whole movie. If I am watching from here, I don't understand what had happened in the previous case. So hence the contextual is very important case in the RN. And the importance of context conditioning, it captures the temporal dependencies. RNN learns relationship across time, and it improves the accuracy. The second point is it improves the accuracy. Contextual information reduces the prediction errors, and it maintains continuity. Output remains consistent and meaningful. And the equation is given by y of t is not equivalent to f of x of t. Y of t is not equivalent to, that means what? It is not there. We cannot say exactly it is not equal to f of xt. So I cannot understand a joke without hearing the full story. So means y of t is not equal to f of x of t. So coming into the summary, RNN model sequence using context in the sense they handle ordered data. RNN handle the ordered data effectively, and the context is stored in the hidden states. Memory is updated continuously, and human-like understanding is achieved. RNN mimic how human process sequences. The equation is given by h of t is equal to h of t is equal to y of t is belongs to y of 2. So say for example, just like humans learn from experience, RNN learn from the past data. Just like my experience helped me make better decisions in life, past data helps RNN makes better predictions. So that is why, so R h of t depends on y of t. Always this output should depends on the, in order to take the better decisions, should the RNN should learn, that is should remember the past data, which will help them make decisions better. Hope all you have understood about this topic, the sequential modeling in RNN. The remaining things we'll discuss in the next lecture. Thank you.